Okay, hi guys. So I'm making a track for a 1-inch steel marble or 1-inch steel ball, and so I used the drill and chucked up just a deep socket and wound some 12 gauge copper wire onto the spool, and then drew a line on each side and then cut those lines so that I got little half circles of copper that look like that. And so now I'm soldering these copper loops onto the copper track wire. So I have a forceps that I can clamp the half loops on, and just reposition this a little bit. So I have these wood blocks that are 3/4 inch wide. They're the spacers for so I get the track consistent, the width consistent. And so then line this up on the track. I'll weight this end of the forceps down to hold it into position, and then I'm using MAP gas. It's a little hotter than propane. For this heavy copper wire, it takes quite a bit of heat because the copper dissipates the heat so quickly. So got my solder, my torch, and I don't heat up right where the joint is. I heat the wire slightly back of where the joint is going to be. That way sometimes the heat will tarnish the wire a little bit and won't allow the solder to stick. You got to get the wire hot enough to melt the solder directly, and both the loop and the wire need to be hot enough. And so there's one joint. Do the other one here. Oh, by the way, I have a piece of metal that I have down on the table so I don't burn the table and the plan and everything. So that's how you solder the loops onto the track. There we go. Hi guys. So finally got this the robot arm working for the steel marble track. There were a couple of issues. One, the magnet was drawing too much current. So anytime anytime the magnet turned on, then it was like a direct short to the power supply. So it has a crowbar circuit in the power supply that shuts it off if it sees a short. So I needed to wind a new magnet that was drawing less current. So the max current for my power supply is 1 amp, so what I ended up doing is putting 200 feet of 30 gauge wire on this magnet. That gave me enough resistance to draw just over half an amp. So that was fine, but then because of the added weight of the magnet, all that extra wire, plus the steel ball, 1-inch steel ball, I had a problem with this, the first servo. There's 3 servos in here. One servo that does the rotation, one servo that moves this arm, and one servo that moves this arm. And the first arm then wasn't strong enough with all that weight and the lever arm. So I replaced the servo with a more powerful servo, and so now I'll show you how it works. So the comes down, picks up the ball, and the magnet's controlled with a FET transistor. And I use an Arduino to control the 3 servos and the turn on and off the FET. So there we go. Got it working. Well, most of the time. Might have to make something so that the ball gets caught on the top there better, but anyway, that's how it works. Please like, subscribe, and share this video. Thanks.